All right, we left off with number 7, and we are trying to evaluate this limit, the limit as x approaches 9 of the square root of x minus 3 over x minus 9. So let's look at direct substitution first, right? That's always our go-to method. Hopefully my pen will connect. There we go. All right, so I'm going to try direct substitution, which would be the square root of 9 minus 3 over 9 minus 9, and I end up with 0 over 0, which means I need to keep going. And when I see a square root, most of the time when I keep going, the way that I keep going is not by factoring, although it could be, and I'll show you that in a second, but rather multiplying by what we call the conjugate. So the conjugate is what will force a difference of squares. So the square root of x minus 3, if I multiplied that by the square root of x plus 3, then across the top, I'm going to get a difference of squares. But we all know from math, whatever you do to the numerator, we need to do to the denominator so as to keep things in balance, right? We haven't changed the value of this expression at all. So now what I'm going to have is the limit as x approaches 9 of, on the top, I multiplied by the conjugate of the numerator. So I'm actually going to do that first, outside, inside, last. And I'm going to end up with x minus 3 square root of x plus 3 square root of x minus 9. And then this is all over. I'm going to leave these as they were, x minus 9 and the square root of x plus 3, for a couple reasons. One, the purpose of the conjugate was to help me with the numerator. The only reason why it's even appearing in the denominator was to keep things in balance. Two, ideally, something is going to be able to cancel out, and so I want to keep the bottom in factored form so I can see what clears from top to bottom. So negative 3 root x plus 3 root x is going to leave me with the limit as x approaches 9 of x minus 9 over x minus 9 square root of x plus 3. And now hopefully you can see, oh, x minus 9s are going to cancel. So my brand new limit problem will be the limit as x approaches 9 of 1 over, because when you cancel from top to bottom, you still have a 1 in the numerator, 1 over the square root of x plus 3. And now when I try direct substitution, I get 1 over the square root of 9 plus 3, which is 1 over 6 for a final answer. Okay? So when you see something with a square root, multiply by the conjugate. So this was subtraction, this then is addition, so that we can get a addition and subtraction will get us a difference of squares, okay? Other thing to note is that on the bottom, you do not need to multiply them in, because the only reason why this is showing up on the bottom was just to help us with this situation. Okay, but then there's also one other way that you could approach these if you wanted to. Just give you a little insider tip for watching this video. Usually we talk about the difference of squares being perfect squares, right? So x squared minus y squared would factor into x plus y, x minus y. And this usually happens, again, when we have perfect squares. Well, x minus 9 does factor. The square root of x is the square root of x and the square root of x. And minus 9 would factor into plus 3 minus 3. So now, if we compare that with the top, square root of x minus 3, these are going to cancel. I get 1 over the square root of x plus 3, which is exactly what I ended up with after I did all of my conjugate work. So if you see this as a factoring situation, a difference of 2 squares, you can. It just gets a little bit messy with the square root. All right, number 8, find a quadratic in vertex form that has these qualities. So first of all, you want to remember that vertex form is sometimes viewed as transformational form of a parabola. It's ax minus h squared, you got to have the square, plus k. And the things that we know is that a creates our vertical stretch or shrink, and then the coordinate point hk is counting as our vertex. Well, great, we have a vertex of negative 4, 6. So the first thing I can do is say, what I do know about my parabola is x minus h squared plus k, right? This is h, this is k. So I'm going to clean that up a little bit. I'm going to have f of x equals a times the x plus 4 squared plus 6. And this makes sense because your vertex is that key original origin point of the parabola. So we will have moved left 4 and up 6 from our transformations. But then the last thing I need to figure out is if I'm going to force myself to fit through the point 1, negative 3, I need to find a vertical stretch that's going to allow me to do that. So 1, negative 3 is an x, y coordinate point, which means that when y is negative 3, it's because x was 1. So I'm going to fill in my x and my y. Negative 3 then is equal to, be really careful with your order of operations here. Negative 3 is equal to 25a plus 6. I'm going to subtract 6. I'll get negative 9 equals 25a, which means that a equals negative 9 25ths. So your final answer needs to go back to that original vertex form. We now know that our a value was negative 9 25ths, and we know that our HK values created this 4 and this 6. And so this is our final answer for our parabola in vertex form. So remember with vertex form, there's also, if you were given an equation, you could complete the square to get vertex form. In this case, we had to build a vertex form based on 2 coordinate points provided for us. All right, to complete the division problem below, we're going to be doing some long division, it looks like, because I have a quadratic term in the denominator as opposed to a linear term. So remember to set up your long division. We have 1x to the 4th minus 3x to the 3rd plus 5x squared minus x plus 2. I didn't need any placeholders. Here I'm going to have x squared plus 3. All right, so I start the division process. X to the 4th, and I'm going to divide by x squared. And I get x squared, so I put that in the squared column. That was the divide step. Then I multiply. X squared times x squared gets me x to the 4th. X squared times 3 gets me 3x squared. Notice again, I'm putting this in the squared column. So I divided. Then I multiplied. Now I subtract. X to the 4th minus x to the 4th is 0. Negative 3 minus 0 is negative 3. X cubed. 5 minus 3 is 2x squared. Bring it on down and bring it on back. Next one then, I start the whole thing over again, a new round of division. I'm going to have negative 3x to the 3rd. And I'm going to divide that by x squared. So negative 3x to the 3rd. Oh, technology. All right, negative 3x to the 3rd divided by x squared gets me negative 3x. Notice I'm in my linear column. So I divided, now I multiply. Negative 3x times x squared is negative 3x cubed. Negative 3x times 3 is negative 9x. And then I'm going to subtract. Those will cancel, just like those canceled. 2 minus 0 is 2x squared. Negative x minus a negative 9 is going to land me at positive 8x. And then 2 minus 0, we still just get 2. Last round, 2x squared divided by x squared leaves me with 2. Then I multiply. 2 times x squared is 2x squared. 2 times 3 is 6. Then I subtract. These are going to cancel as they should. 8 minus 0 is 8x. 2 minus 6 is negative 4. When I try this last round, 8x divided by x squared does not leave me with something with a polynomial, so this becomes my remainder. So plus 8x minus 4 when I was dividing by x squared plus 3. So my final answer is this up here that I've boxed in. It wouldn't hurt ya on a test or a quiz to rewrite that just over to the side. Your final answer is x squared minus 3x plus 2 plus 8x minus 4 over x squared plus 3. Okay, so what you found is that this is mathematically the same as this, just rewriting it in a little bit different way showing our division. All right, find all of the zeros. Find all of the zeros. Well, to start, you want to try to factor if possible. So when I look at f of x, I notice that each term has an x. So I'm left with x to the fourth plus 3x cubed plus 5x squared plus 27x minus 36. So I know one of my zeros is x equals 0, right? From there then, I'm looking for 4 more zeros, 4 more factors, 4 more roots that will come from this x to the fourth. So the way we want to do that is graph on our calculator. And when you graph on your calculator, if you go to y equals, you can type in just this part. This is the part we care about. All right, we've already divided out by our 0, 27x minus 36. And when you do this, you will see that x equals -4 and x equals 1. So there's 2 more zeros that come from our calculator. Okay, so again, the red one, this was from factoring. These ones come from our calculator, more specifically factoring with a GCF. So now what we want to do is we want to take our function and we're going to divide by the 2 zeros that our calculator gave us. So I'm going to put a -4 up in the box. And then across the top for synthetic, I'm going to pull all of my coefficients, starting with the leading coefficient of 1. My pen is really struggling. So we have 1x to the fourth, 1x to the fourth, 3x to the third, 5x squared, 27x, and -36. No need for a placeholder because I have each one of my descending terms. 1, -4 times 1 is -4, -1, -4 times -1 is 4. This is 9, -4 times 9 is -36. This becomes -9. -4 times -9 is 36. Remainder of 0, as it should be, because we knew -4 was a 0. So then I can, right now I'm at the cubic level. So now I'm going to divide out by this 1. And I continue my synthetic, bring down the 1. 1 times 1 is 1. 0, 1 times 0 is 0. 9, 1 times 9 is 9. This becomes 0, as it should, because we knew that 1 was a 0. So if I was at x to the fourth, and then I dropped to x to the third, this then becomes x squared. So what I'm left with is x squared plus 9. I'm going to set that equal to 0. X will be equal to plus or minus the square root of -9, which means x is equal to plus or minus 3i. So I ended up with 5 zeros, which makes sense because I started with x to the fifth. So 1, 2, 3, 4, 5 zeros. If I needed to write this in factored form, let me just erase this real quick. I already factored out my x, right? So f of x is equal to x. I already took that out. I also would have x plus 4, x minus 1, and x squared plus 9 would be my factored form. All right, I'm going to stop there, and I will pick up with one more video for the remaining problems.